Hello, guys. Very good morning. Welcome to the fundamentals of aerospace engineering lecture. Today, we're going to see the topic on landing gear structures and power plant. This is Professor Nehru, Department of Aerospace Engineering, SNS College of Technology. So, we already discussed about these few topics on the previous lecture, like aircraft structures, components, the basic fuselage structure, wing structure, component structure. Today, we'll see the remaining part of the power plant and the landing gear design or the structure. So landing gear structure is one of the primary component in the aircraft flying machine. The landing gear is a principal support for the airplane when parking or the taxiing or takeoff or the landing. The most common type of the landing gear consists of wheel, but airplanes are also equipped with floated on floated on water optionally if required, or skidding device in the snow or the ice region. The landing gear consists of three wheels, two main wheel and the third wheel positioned either at the front or rear of the airplane. The landing gear employing a three-mounted wheel is called conventional landing gear. The airplane with conventional landing gear, or sometimes referred as a tailed wheel airplane, when the third wheel is located on the nose, it is called nose wheel and the design is referred to as tricycle gear. A steerable nose wheel or tail wheel permits the airplane to be controlled throughout all operation while on the ground or in the runway. So in the picture, we'll see the landing gear is located both retractable and non-retractable. In this both picture, we'll understand the landing gear in a traditional and the tricycle landing gear model. Next, coming to the landing gear arrangement, based on the main and the nose wheel arrangement, we have single main wheel, bicycle main wheel, or quadricycle main wing. These are the side views of the landing gear, and we have the tricycle model landing gear, tail geared landing gear, multi bogie model landing gear, releasable releasable landing gear or releasable rail landing gear, and skidding device, which is used in the ice surface and snow region, and floater device will use in the water region. Coming to the next components of airplane is power plant. Power plant usually includes both the engine or the propeller. The primary function of this engine is to provide the power to the propeller. It is also generates electrically powered, provide a vacuum source of for from flighter instruments, and in most single engine airplane provides a source of heat from the pilot and the passenger. The engine is converted by a cowling, covered by the cowling, or in the case of some airplane, surrounded by the nacelle. The purpose of this cowling or nacelle is to streamline the flow of air around the engine and to help cool the engine by ducting air around the cylinders. The propeller mounted on the front of the engine translates the rotating force of engine into a forward acting forces called thrust that helps to move the airplane through the air. So here we have the types of aircraft power plants. One is a reciprocating engine, and second is power type and reaction type. In reciprocating type, we have inline piston engine, V type piston engine, opposite piston engine, and radial piston engine. And rotary Wankel we have used. In power type, we have turboprop, turboshaft, turbofan, and electrical powered aircraft engine. For reactive type, we have turbojet, turbofan, pulse jet, ramjet, scramjet, rocket engines, and hybrid engines. So this is the types and classifications of power plant with different operation, different benefits are there by using these types of power plants. Let us take a jet engine, which is usually used in our airplanes. The construction view of this jet engine, we have air inlets that we call as an inlet, and compressor region, combustion region, and nozzle or exhaust region. So between combustion and exhaust, we have the turbine, which help us to rotate the compressor blades, rotary blades. So we have the first stage compressor and second stage compressor. In intake, air will be intake from the atmosphere, and compressor which used to compress was the rotors and stator we have. In combustion chamber, we have three types of combustion chamber: can type, annular type, and can annular. There we have the spark plug and sprayer. There we'll use to mixing the fuel and the air, and with high temperature and high velocity, it will comes to hitting the turbines. The turbine blade will start rotating, and the nozzle or exhaust producing the thrust in the jet engine. So this engine is mounted in the aircraft commonly used to commercial airplanes. Since fuel is carrying on the wing and less noise can be transmitted to the inside the cabin, CL maximum is not as good as fuselage mount. Yawing moment effects will not be created, and around ground clearance limitations, higher gear stud. So this wing pod mount is creating the yawing moment and the ground clearance, whereas fuselage mounted model, the engine is mounted in the fuselage. Here we have the clean wing, high CL max, shorter takeoff we can do, no ground clearance is limited, less yawing effect will be created due to the close to the CG. Weight penalty after CG and load distribution may be reduced. Cabin noise and vibration is the main issue if you mounted engine at the fuselage. So here we are concluding the engine power plant in this class. We'll see the next topic in the next class. Thank you.